This should represent the last of the optimization problems. Here is number 10. This problem is trying to find the maximum volume cylinder that will fit inside of a sphere. It says, so find the dimensions of the right circular cylinder of maximum volume that can be placed inside of a sphere of radius r. So they don't tell you what r is, but r is a constant. Now when they say find the dimensions, they want two things. They want the radius, so the radius from the center to here. So let me draw it in. I've drawn a picture of the situation here. I didn't mean to use white, so we'll use black. So that'll be little r, and then they'll want h. And those are the dimensions that they're looking for. So the objective function is we want to find the maximum volume. Well, the maximum volume of a cylinder is the area of the base times the height. So it's pi r squared times h. And of course what I need to find is the connection between r and h. Well, there's a very simple one. If I extend this line all the way to the end, I have a base of 2r. And then if I draw this line from this corner, there we are, then this length here is 2 capital R. But this length down here, I'll take this little r out. This is 2 little r. So the triangle that I'm drawing looks like this. It's a right triangle. You have 2 little r down here. You have 2r for the hypotenuse, and then h for the height. So the Pythagorean theorem can be used to get an equation involving all three of these. I'll have 2r squared, so that'll be 4 capital R squared equals 2 little r squared, so that'll be 4 little r squared plus h squared. Now, in the formula, I can replace either r or h. I think it'll be easiest to replace r squared because down here I already have an r squared. I don't have an h in here, so I don't want to bother with doing too much solving for the variable. So I'll solve this equation for little r squared. So the first thing I'll do is subtract h squared. So I get 4 capital R squared minus h squared equals 4 little r squared. And then I'll divide by 4. I find that when taking derivatives, it's easier if I rewrite this left-hand side as capital R squared minus 1/4 h squared, and that's equal to little r squared. And now I can throw that into my volume formula. So V equals pi little r squared h, which equals pi, and in place of little r squared, I'm going to put capital R squared minus 1/4 h squared, and then I have times h. So now V is a function of h. And one last thing to make the derivatives easiest, I'm going to multiply the h through. So I'll get V of h equals pi times capital R squared h minus 1/4 h cubed. Now, what is the domain of the volume function? Well, let's go back to the picture. Obviously, if h is 0, that means there is no height to this thing, which I'm not so sure that h could. Yeah, I guess so. What you could have is it could be a flat disk centered along the main diameter. So that would be an h of 0. H of 0 is actually possible. So let's calculate these. V of 0 equals, and I think you can see once I plug in 0 for h, I'll get 0. That's pretty easy. And the most h could be is 2 capital R, because then it'll just be a vertical line going from the bottom to the top of the sphere. So let's calculate what the volume, well, it's going to be 0, the volume of 2 capital R, but I'll plug it in just to show you that's the case. So I'll have pi times R squared times, now when I take 2R and plug it in for H, 2 capital R minus 1/4, and then I'll have 2R, that quantity cubed, that'll be 8 capital R cubed. So I will get, that'll equal pi times 2 capital R cubed minus 2 capital R cubed. So that equals 0. The domain. We have 0 is less than or equal to H, which is less than or equal to 2 capital R. We've already checked the endpoints. Both 0 and 2R produces 0. So whatever I get in between, whatever critical number I get, is going to be the solution. So let's go back to the volume formula. V of H equals pi times capital R squared H minus 1/4 H cubed. And let me take the derivative and set that equal to 0. V prime of H equals pi times capital R squared minus 3/4 H squared. Now if we set that equal to 0, well, obviously the pi has no bearing on whether it's 0 or not, so I can divide out by that. This part in here, capital R squared minus 3/4 H squared will be 0. I will take the 3/4 H squared to the other side of the equation, so I get R squared equals 3/4 H squared. Multiply both sides by 4/3, so I'll get 4/3 capital R squared equals H squared. And then solving for H, I will get 2 over the square root of 3 capital R equals H. And then what is little r going to be? Little r, well, I had R squared, which was little r squared, where did you go? Was capital R squared minus 1/4 H squared. So I'll go ahead and take the square root of that. So I'll leave the R squared obviously, but I'll replace H squared with 4/3 R squared. Capital R squared minus 1/4 times 4/3 capital R squared. That is R squared minus 1/3 R squared. So that'll end up being the square root of 2/3 capital R squared. And then that will end up being the square root of 2/3 capital R. That's little r. So those are our dimensions. Little r equals the square root of 2/3 capital R. H equals 2 over radical 3 capital R. And there you go.